Hello student, in this video we are going to discuss about reflection of light. This is the part of light chapter 10th grade. In previous video we have discussed about light in detail. What is light? Light is electromagnetic wave. Speed of light is 3 lakhs kilometer per second. Then we have discussed about the interaction of light with matter. And in that interaction, we have discussed about reflection, refraction, diffraction, dispersion, interference, and photoelectric effect also we have discussed. So we have discussed all those points in previous video. If you want, you can watch that video first, then you come to this video. In this video, we'll focus on this topic, reflection of light. So in this topic, first thing which we have to discuss, what is reflection? So reflection, as we know, the definition is bouncing back of light in the same medium after striking a surface. Whenever light will strike a surface, it will bounce back in the same medium. This is called reflection. So light will not pass through the medium. That is refraction, when light will pass from one medium to another medium. But here it will bounce back in the same medium. So that's why we have given this definition. Now, there are two laws, which rules it has to follow. Light will strike the surface, then we have two laws which has to be followed. So first law is the angle of incidence is equal to angle of reflection. So this is first rule, I equal to R. Second rule, we have incident ray, normal and reflected ray all lie in the same plane. So the meaning of same plane means, suppose this is the incident ray and incident ray will strike the surface. Suppose this, in most of the case we take mirror, because mirror is the best reflector. That's why we take mirror as a reflecting surface, because it will reflect back all the light which is coming in. So this is incoming rays are known as incident ray. So incident ray and normal is always 90 degree to the surface. So incident ray and normal will make a plane. Now reflected ray has the compulsion that it will remain in the same plane which was made by these two lines. With the help of two lines we can make one plane. With one line we cannot make any plane, right? So we need at least two lines to make a plane. So two coordinates, x and y coordinate we can say. Plane can be represented with the help of these two coordinates, x and y coordinate. So here we have two lines. So with the help of two lines we can make one plane, and this third line, which is the reflected ray, it has the compulsion that it will remain in the same plane which was made by these two lines. So this is the meaning of the second law of reflection. All lie in the same plane. Reflected ray, incident ray and normal all lie in the same plane. Now this law of reflection is valid for all kinds of surface. It's not like only plane surface. Even laws of reflection is valid for this rough surface also, and plane surface also, shiny surface also, or any surface. Here we have taken two examples of concave and convex mirror. Here this is not a plane surface, this is curved surface. So in this case also the I equal to R, this law will be followed. So I is always equal to R in all the cases, whether light is falling on a plane surface or curved surface or even on rough surface like this. So this is the law of reflection, first part. Now after this we have to discuss about the image formation by plane mirror. So image can be formed with the help of, because we can see our image in the plane mirror, as well as we can see the images in concave and convex mirror also. So these 3 points we have to discuss in this chapter: image formation by plane mirror, then we have to discuss about image formation by concave mirror and convex mirror. So these are the 3 type of mirror where we have to show the image formation, how to form the image. So first we'll see how image is formed in plane mirror. So plane mirror, whenever we have plane mirror, we can show the image formation like this. So suppose here we have one object. This is plane mirror. This M and M is the surface of plane mirror, and here this is the reflecting surface. So we have to place object left hand side here. If you place the object here, now look, in all cases we have to follow the same rule, angle I equal to angle R. The same rule has to be followed. So here, suppose first ray we are taking this one. Here this is the incident ray, and what is normal? Normal is 90 degree. So here they have mentioned here, this is 90 degree. So normal is 90 degree. So normal is also on the same line. So angle between this incident ray and normal is 0. So angle I is 0. So angle R should also be 0. So that's why the ray which was coming, like this is incident ray, reflected ray will remain on the same path. It will trace back the same path which was taken by the incident ray. So that's why this is the first ray. It will reflect back and it will retrace the same path. Now second ray, any other ray we can take from the same point. So suppose we can take any other point, this point or even like this, but I equal to R is always, in all conditions we have to follow this rule, I equal to R. So this is the second ray which they have taken. So here at the we have to place the object at the principal axis, and here object is placed, and we have taken two rays from this point. Suppose this is a candle. So here there are infinite rays which are passing through it. We will take only two rays because two rays are enough to show the image formation. Although there are infinite rays which are taking part in formation of this image, but we have to take only two rays. With the help of two rays we can show the position of image. So here that's why we are taking only two rays. So first ray parallel to the principal axis, and since it is normal, so it will retrace the path. Second ray we can take any other ray, and so but only thing which we have to take care is I should always be equal to R. So this is the second ray. Now these two rays, these are the reflecting rays, this one and in first case this one. So these two rays are moving away from each other, they are diverging, so they will never meet. So that's why we will not get image this side, LHS, right hand, left hand side. So what we do, these two rays which are diverging rays, we'll assume that they are coming from somewhere back side. So here they will meet at point A. So here the image will form at point A, because these two are the extended ray, like these two are the reflected ray, and we have to extend this. So we will assume that this is coming from A. So now this is the intersecting point. So image will form at this position. So like this we can get the image formed by the plane mirror. Now there are some properties of the image formed by the plane mirror. It is always virtual and erect. So here this is erect, like this is the side. So these two are similar. It's erect. And it is virtual because this image is formed with the help of virtual rays, not real rays. These two rays are virtual, not real. Next, after that, the second property we have, image size is equal to object size. So this size AB, this size is equal to A dash B dash. Both are same. This also we can prove mathematically. And then object distance equal to image distance, means BO and BO dash, both are same. These two are same distance. This also we can prove mathematically. And last we have laterally inverted image. Laterally inverted means left will be right, right will be left. You can see your image in the mirror. If you see your image in the mirror, you can see if you raise your left hand, it will look like you are raising your right hand in the image. So that's this property is known as laterally inverted, not vertically inverted. Laterally means left will be right and right will be left. In case of vertically inverted, in that case upside down, like okay, top will go down. So this is these are the property of image formed by the plane mirror. Now if you want, we can discuss about this because this height equal to this height. This we can prove with the help of one property. Where, look, this line is parallel, this line, these two lines are parallel. We have already taken This line, this is parallel to the principal axis, like this is B and B dash is the principal axis. So this line is parallel. So here this, the whole line, and we know that the distance between two parallel lines is always same. You take any, so this distance is always same. That's why these AB and A dash B lie between two parallel lines. So that's why these two will be equal. So object, this we proved that image size is equal to object size. Second thing which we have to prove is object distance equal to image distance. That also we can prove with the help of congruency. So suppose this is I, this angle and this angle equal, I equal to R, and these are vertically opposite angles. So this is also I. So this R is also equal to I. So these two angles are equal. Just now we proved that this side is equal to this side, and then third, this angle equal to this angle. So third angle is also equal. So all angles are equal and one side is also equal. So from angle, side angle, we can prove that these two triangles are congruent. So since these two triangles are congruent, so the corresponding side BO and BO dash, OB dash, these two are equal. So this is object distance, this is image distance, these two are equal. So like this, with the help of congruency, we can prove that object distance is equal to image distance. Okay, so this is the image formation by plane mirror, and these are the properties. This is how in the image formation will happen. So this is how we see the object, the image of any object. So suppose object is placed here, always I equal to R, that we have to follow. Whichever ray you take, two rays they have taken from the top of the bottle and two rays they have taken from bottom. But angle I and R will always be equal after reflection. And since these two rays are, like suppose in this case two rays we have taken, these are diverging. So we'll assume that they are coming from somewhere backside. So we'll get the image of this bottle, which is suppose top of the bottle here, we'll get the image at this position. So suppose this is A dash, and here this is B, then this will be B dash. So we can take two rays from the bottom and two rays from the top, and we can form the image. So this is what is happening in reality. This type of image we can get with the help of plane mirror. Although each and every part is contributing, because we are getting the image of the whole bottle, not only top and bottom. So it means each and every point of the bottle, light is going and it will strike the surface of mirror and it will bounce back, and those reflected rays will enter into our eyes and will get the image. But these rays will assume that these rays are coming from somewhere, and there will get the image. So this is the object and this is the image. This is how image is formed in plane mirror. Next, after this plane mirror, we have a spherical mirror. A spherical mirror means the mirror which is made up of a sphere. So this is part of a sphere. That's why we call it a spherical mirror. There are two types of a spherical mirror: concave mirror and convex mirror. So suppose a spherical mirror is curved mirror, which is a part of hollow sphere. Like suppose this is the hollow sphere, this part. So this is a hollow sphere, and if you cut one part of it, like suppose you cut this much and you remove it. Now you paint outer side, this side, with the silver or aluminum, then this will become concave mirror. And similarly, again you cut the same part and you remove it from this sphere, this is hollow sphere, and you paint the inner side, this one, then this will behave like a convex mirror. So concave mirror is the mirror which has the reflecting side curved inside, like this. In case of concave mirror, reflecting side is curved inside, and in case of convex mirror, reflecting side is bulging outside. So this is the two difference of concave and convex mirror. So now in case of concave and convex mirror, there are only two types of the spherical mirror, concave and convex. So now if you see, if you take the parallel rays, like then this is the property of this mirror. Whenever parallel rays are coming, after reflection they'll meet at a single point. Like suppose here, after reflection, what will we see? All the rays will merge at a single point, and this is known as focus. This is the principal focus. Same thing will happen with this also. If you take this mirror, convex mirror, after reflection, suppose this will strike the surface and after that it will reflect, but this is diverging mirror. So convex mirror is diverging. After reflection, we'll assume that because these are diverging, so we have to assume that these rays are coming from somewhere backside. So now these rays will appear to meet at a certain point, and that is also known as focus. Okay, so this is about focus as well as the property of these mirrors. This concave mirror is converging mirror, convex mirror is diverging mirror, and all the parallel rays will meet at a certain point after reflection, or it will appear to meet at a certain point. Here, these points are known as focus. Okay, so these are the two property of a spherical mirror. Now we have to discuss about few terms which are related to the reflection of light and image formation by the concave and convex mirror, spherical mirror. So in case of a spherical mirror, we have to discuss few points, because for image formation these points are very important to understand. So first we will understand about the pole. First point which we have to discuss about is pole. So pole is the center of the aperture of the mirror. So pole is always on the mirror, like it is not away from the mirror. So it will lie at the center of the mirror, center of the curvature, center of the aperture. Then we have center of curvature. Center of curvature means that point which was the center of a sphere which we have considered. So suppose center of a sphere, because concave or convex, you take any mirror, it is the spherical mirror, it is the part of a sphere. So that a sphere will have some center. So this point is known as center of curvature. So center of curvature is the center of the sphere of the spherical mirror. So sphere with which we have made this concave mirror, so that is the center. Same for the convex mirror also. So this will be the center. So center of curvature means center of the sphere. Now after that we have to define focus. Focus we discussed in last slide also. Those parallel rays will meet at a certain point on the principal axis, and that point is known as focus, principal focus. And apart from that, we have to discuss about the principal axis also. Principal axis means the line joining center and pole. So if you join these two lines, center and pole, so this line is known as principal axis, at which we will place the object. And radius of curvature also is, because this is center, so obviously this length will be radius of curvature. So this is a radius, because radius of the sphere is known as radius of curvature. So after this, one by one we'll see how images form. So next point which we have to discuss is the intersection of to form the image, we need, as we discussed, to form the image we need two rays. With the help of two rays we can make all the images. All those, like suppose we have one concave mirror like this, and we have to draw, just now we discuss about the points which we have discussed. So first point which we have to discuss is pole. So pole is the center of the aperture. This is suppose pole, and suppose we have focus here and center of curvature here. So we have to define all the points first. After that, if you place the object somewhere, you can place the object. Now there are how many situations? There are 6 situations. So first situation is when you can place the object at infinity. So object position at infinity means infinity means object is very far from the mirror. Second position, you can place the object somewhere between center and infinity. This is the second condition. So you have to place the object between center and infinity. Then third situation we have, you can place the object at center. Fourth situation, you can place the object between center and focus. And fifth situation, at the focus. And sixth situation, you can place the object between center and pole. So these are the 6 situations. Why we are taking 6 situations? Because in all these situations, all these 6 situations will get the different type of image. The property of the image will change. So we will get 6 type of image with the help of these concave mirrors, 6 type of images. So, and to form the image, we can place the object anywhere. So suppose we'll place the object here beyond C, means between center and infinity. So in that case, now look at this situation, because suppose this is a candle. So light is coming out of it in all directions. There are infinite possibilities, infinite rays are there, but we'll take only those rays which are very convenient for us. So which rays are convenient? So first ray will take parallel to the principal axis, and this will always pass through the focus. Why? Because look, if you draw a line like this, if you join at this point of incidence, then this is the normal for this concave mirror. Normal, because this is the perpendicular. If you draw a tangent here and you join this line C, this will always be perpendicular 90 degree. So that's why this the line joining C and this point of incidence is normal. So this is your I and this is your R. I is always equal to R. So if you take the parallel ray, it will always pass through the focus. So this is your first ray. Now second ray we can take the ray which is passing through the focus. So first ray we have taken the ray which is parallel. Second ray just opposite, because parallel ray was passing through the focus. Now you take rays which is passing through the focus. So it will be parallel after reflection, just opposite. So first ray parallel to the principal axis, it will pass through the focus. Second ray passing through the focus and it will be parallel to the principal axis. So these are the 2 options which we have. We can have the third option also. So third option, you can pass the ray through the center. So in that case, we know that this center and this point of incidence, this is normal. So here I is 0, here I is 0. So that's why R will also be 0. So light will go and it will retrace the same path. So these are the 3 rays which we can take. Out of these 3 rays, we'll take any 2 rays to form the image. For image formation by concave. So in case of concave mirror, we have these 3 rays which we can take and we can form the image. We'll see one by one which all rays are convenient for us, but these rays are well defined rays. So first, second and third. These are the 3 rays which are well defined, although there are infinite rays which are passing through it. And in all case, I is always equal to R. In all cases, you can prove this also. You can show this. I is always equal to R. Here also, in case of the light which is ray which is passing through center, here I is 0, so R is also 0. I equal to R, we have to take care. So this is the only thing, I equal to R, which we have to take care. So with the help of this angle I is always equal to angle R, we can have some well defined rays. So the rays, these are the 3 rays. Out of these 3, we can take any 2 and we can form the image. Same thing for the convex mirror. So suppose we have one convex mirror like this. So in case of convex mirror, the reflecting surface is bulging outside. Now you draw one principal axis. Now here first we have to define focus. Focus will be behind the mirror and this is the center of curvature. So ray which is parallel to the principal axis will, now it is diverging mirror. So that's why ray will diverge like this, but it will appear that it will pass through the focus. Right. So these are the virtual lines which will meet at the focus. So this is your first possibilities. First ray which we can take to form the image. Second ray, like suppose here we have the object. So one ray we have taken parallel to the principal axis which will appear to pass through the focus, because in reality it will not appear, it will diverge. Now second ray you can take the ray which is passing through the center. Like suppose here we can take this ray passing through the center. So now look, we got two rays. These two rays. Suppose this was the object. So image will form at the intersecting point. So here we'll get the image. So this is the second ray. Because the ray which was passing through center will diverge and will retrace the same path, because rays which are passing through the center is the, like this line is normal. So here angle I is 0, so R will also be 0. So it will, these two rays are diverging, so they'll meet somewhere here. Wherever they'll meet, the image will form. So these two rays we can take in case of convex mirror. So first ray parallel to the principal axis, second ray the ray which is passing through the center. Third ray we can take any arbitrary, any point, like suppose you can take ray which is at like this point, it will strike at the pole. So here angle, this is angle I, so angle R, this angle I and R should be equal. So we can take this ray also. So here it will go back. In all these cases, these rays are virtual rays. Even this yellow color ray, this is also virtual ray, this is not real ray, because a ray will go and it will return, because this is reflecting surface. So these three rays, these three, again here also we got three rays, first parallel to the principal axis, second passing through the center, and third we can take this one also, which will fall on the at the pole. So only thing which we have to take care is angle I should be angle always equal to R. So these are the three possibilities. So three type of rays. So out of these three, here we in the figure you can see first ray parallel to the principal axis, it will pass through the focus. Second ray in case of convex, same thing, parallel to the principal axis, it will appear to pass through focus. This is your first option. Second option, if ray is passing through the focus, it will be parallel. This is your second option. Same thing for the convex mirror also. The ray which is passing through the focus, it will become parallel after reflection. This is your second option. Third option, the ray which is passing through the center, it will reflect back to the same path. So here this is your third option. Same thing with the convex, it will go and it will retrace the same path, but it will appear to pass through the center. Fourth ray, fourth option, these three options are enough to form the image. In some situation you can take this also, it's optional. So the only thing which we have to take care is angle I equal to angle R. So if ray is coming like this, it will go like this. Here also like this. So here we have the four option. Out of these four option, any two option we can take according to our convenience, and we can form the image. So these are the four options. So these are the options to take the rays. Now image formation by concave mirror, one by one we will discuss. As we discuss that there are 6 situations. In case of just now we discussed, in case of concave or convex, in case of concave mirror we have 6 situations, because here we have focus and here we have center. So first we have to place the object at infinity. Second, somewhere between infinity and center. Third, at the center. Fourth, between center and focus. Fifth, at the focus. And sixth situation, between pole and focus. So these are, so one by one we will see each situation. And in case of convex mirror, we have only 2 situations. One at infinity and second anywhere. So only 2 type of image we will get in case of convex mirror. And in case of concave, we have 6 situations. So here 6 ray diagram and here 2 ray diagram we have to draw. So this is the first ray diagram when you place the object at infinity. If you place the object at infinity, so all rays will be parallel to the principal axis. All rays which will come will be parallel to the principal axis, because they are coming from very far. So that's why rays will be parallel to each other. So just now one example, like suppose sun. From sun, all the rays which are coming are parallel to each other. But if you take a bulb here, suppose, so the rays which are coming out of this bulb will not be parallel to each other because it is very close to the mirror. If you bring this ball very far, like if you shift this ball very far, then what will happen? Between these two rays, the angle will decrease. So ultimately these two rays will be parallel to each other. That's why we say that the rays which are coming from sun is parallel to each other, because the angle will decrease. Angle between two rays will decrease. So for understanding purpose, I'll explain it again. So here look, suppose one bulb is there. So here if you take this point, so here two rays are coming. So these two rays are, the angle is suppose 30 degree. Now you shift this bulb. Now this was the first situation. Now you shift this bulb to this position. Here the same bulb. Now what will happen? These two rays, if you look at this, now these two rays will be, the angle between these two rays will be less. So slowly if you shift this bulb to the infinity, then slowly these angles will become 0. So these two rays which are coming from this very far object, those two rays will consider as parallel to each other. So this is the condition. That's why we take first situation. In first situation, whenever object is at infinity, rays which are coming from that object are always parallel to each other. And here in this condition, we will consider these two rays are coming parallel to the principal axis. So they will always meet at the focus. You can take this ray also, it will also meet at the focus. So any ray you take, it will meet at the focus because this is parallel to the principal axis, and we don't have any other option. Rays are always parallel to the principal axis. So this is first situation. So image will form at the focus, and this is real because these rays are real. So image formed is real image. So this is real, and since it is real, so we have to consider it as inverted, and it is highly diminished. So point size we can consider. So here image distance is equal to focal length also. So these 4 points we have to keep in mind. So the image form is real because this image is image form is with the help of real rays, not the virtual rays. So that's why image form is real, and it is inverted because it is real means inverted. Real always we have to take inverted. Although this is a point size, point is not inverted or erect, but since it is real, so we have to consider inverted rays. And then second situation was like whenever you place the object between infinity and center. This is your center. So whenever you place the object between infinity and center, so first ray will always, in all conditions, this ray is same. First ray will take which is always parallel to the principal axis. It will pass through the focus. This is the first ray. Now second ray we have option. You can take any ray, like you can take this also, the ray which is passing through the focus. It will be parallel. Or here they have taken in this diagram two rays, first ray parallel to the principal axis and second ray passing through the center. So the ray which is passing through the center will retrace the same path. So that's why here we got these two, one reflected ray is here, another reflected ray here. They'll intersect at this point. So we'll get the image between center and focus. So image form is between center and focus. And you take any rays, any out of those 4 options, we can take any 2 rays, and but image will form always at the same position. So here image is formed between center and focus, and it is also real because it is made up of these real rays which are intersecting at a particular point, and these are inverted and it is diminished, it is smaller than the object. Now third situation, when you place the object at center itself, this is center. So when you place the object at center, first ray as usual, first ray which will be parallel to the principal axis and it will pass through the focus. Second ray you can take this one. Now this option we don't have, we cannot pass the ray through the center itself because at the center object is placed. So second ray we have the option, we can take this one. We can pass the light, this ray through the focus. It will be parallel after reflection. Now these two rays will meet at certain point, and if you see these two rays will meet at center itself. So here not at center, like this distance, like object and image is formed at the same place at the center itself. So here the size of, now this is the property, this is the nature of the image, this is also real, this is inverted and equal in size. So initially it was very small point size, now in second case it was smaller, in third case it is now equal size, but real, because real rays are intersecting. So that's why we'll get the real image. So these are the three situations. Now three more situations we have. Fourth situation we have, when you place the object, now slowly we are shifting the object towards the mirrors. In first case it was at infinity, and then between infinity and center, and then at the center, and now between center and pole. So we have to place the object between center and pole. When you place the object, again first ray always parallel to the principal axis, which will pass through the focus. First ray we got like this. Second ray, now object is not at the center, so we can pass the ray through the centers. But the ray which is passing through the center will always will not divert, like it will retrace the same path. So this is your reflected ray. So it is going like this, and this is normal, angle I is 0 here. So that's why here angle I and angle R is 0. So that's why it will retrace the path, and these two rays will meet here. So here image will form beyond C or between center and infinity. Now look, now in previous situation image was equal to object size, image size was equal to object size. Now in this situation image is bigger. It is inverted, real, but now magnified. It is bigger than the object. Now fifth situation when we have to place the object at focus itself. In that case again, first ray will be parallel to the principal axis, it will pass through the focus. Second ray we have option, either you can pass it through the pole, then you have to take care of the angle. Here angle I and angle R should be equal. So you can take this ray, or here they have taken first ray as usual. There is no, this is the most convenient one, which will pass through the focus. In all situations, all 6 situations will take this ray which will pass through the focus. Second ray you can pass it through the center also. Now if you look at these two rays, reflecting rays are parallel to each other, so they will never meet. So we'll assume that they will meet at the infinity. Just like the ray which are coming from sun are parallel to each other, same way parallel rays always meet at infinity. Infinity means very far. So image will be real, because these are also real rays. They'll meet at infinity. So that's why real, inverted and highly magnified. So image will be very large. If you see, it will be very large, because wherever they'll meet at infinity, it will be very large. So real, inverted and highly magnified. Now last situation of concave mirror. Last situation, when you have to place the object between focus and pole. So last situation, this situation is unique, because here image form is virtual, not real. In all 5 situations image was real in all 5 situations, but here we have virtual image. So first ray which will take is parallel to the principal axis, which will pass through the focus. And this is 3-dimensional. Don't think like this ray, this object will block this ray. No, this is 3-dimensional. So image and there are infinite rays. So that's why with the help of those rays also image will form at the same place. So here first ray which is parallel, it will pass through the focus. Second ray you can take passing through the center. But these two rays are diverging. So it will appear that they will meet somewhere behind the mirror. So image will form behind the mirror. So image will form behind the mirror, and it is virtual, because these two rays are virtual lines. So it is virtual, erect. This time it is not inverted, it is erect, and then it is magnified also. It is bigger than the object. And so these are the properties of the nature of the image formed by the concave mirror. So these 6 situations we have to study. Ray diagrams are very important. Almost in every exam, every year they will give one ray diagram, either from mirror or from lens. But mirror and lens are similar. So if you learn mirror here, you can do lens also. Now image formation by convex mirror. So concave mirror over, now convex mirror. So in case of convex mirror, I just now we discussed, in case of convex mirror we have only two situations, first and second, only two situations. In first situation you have to place the object at infinity. So at infinity object is placed. So ray which are coming will be parallel to each other. So image will always form. So like suppose you, second ray also you take. So it will pass through the focus. So image will form at the focus itself. So first ray like this, angle I equal to angle R, diverging. Same thing you can take another ray and it will also diverge, and we can take the normal, angle I equal to angle R. So here after reflection it will appear that those two rays are meeting, they'll meet at focus. So image will form at the focus and it will be very point size. When object is at infinity, image form will be highly diminished and it will be virtual because it is behind the mirror, and it will be erect. Whenever virtual it is erect, and it is highly diminished, means almost point size. Okay, so and image distance is equal to focal length. Now second situation, you can place object anywhere because here we don't have any points. Points are right hand side, focus and center. So in here, and we cannot place the object right hand side because it is opaque. It is not. It is paint. So this is not the reflecting surface. We have to place the object always left hand side because this is the reflecting surface. So and here left hand side we don't have any point. So in only two type of image we'll get. One, when object is placed at infinity. Second, you can place anywhere between infinity and pole. If you place object anywhere, first ray will take parallel, it will appear to pass through the focus. Second ray you can pass through the center itself. It will appear to pass through the center, and these two rays will reflect. So these two rays are reflecting rays. Wherever they'll intersect, that point will get the image. So here we are getting this. So here look, this image, property of this image's nature is, it is virtual, first thing because it is right hand side, it is behind the mirror, so it is virtual. And second, it is smaller than the object, and it is erect because it is virtual, means it is erect. So like this. So these are the 6 plus 2 ray diagram. So 6 in case of concave and 2 in case of convex. So these are the 8 ray diagram which are important, and similar ray diagram we have for lens also. Now last point of this reflection is mirror formula. Now mirror formula, like we have, like suppose we have one concave mirror or convex mirror. So we have concave mirror. So object distance, there is relation between object distance. Suppose you place the object. So this is your object distance. Object distance means the distance between pole and the object. This distance is known as object. We represent this distance with u. And suppose image is formed somewhere here. So this is your v. This point is v. V means image distance. U means object distance. Distance of object from the pole. Distance of image from the pole. With the help of this principal axis. This distance we are measuring at the principal axis. And there focus also we have. So focus, that will be the focal length. So three quantities we have, v, u and f. So there is relation between these three. That is called mirror formula. Mirror formula is relation between object distance, image distance and focal length. So mirror formula we have is 1 by v plus 1 by u is equal to 1 by f. So this is your mirror formula. Means if you know out of these three, if you know two quantities, like suppose u and v you know, then you can find out f. If you know focal length, if you know object distance, you can find out image distance. So out of these three, any two will be known quantities, and a third quantity we have to find out with the help of this mirror formula. And for magnification, we have the formula minus v by u. General magnification is height of image by height of object. This is the meaning of magnification. So magnification height of image by height of object, and this is equivalent to the minus V by U. Minus sign will come. Now here, to apply this formula, we have to follow the sign convention. That is the last topic of this reflection part. So that we have to study about this sign convention. Without sign convention, we cannot apply this mirror formula or even magnification. So we need sign convention. Sign convention means it's a convention. For our convenience, we have taken some rule. So first rule is that sign convention, first rule we have like this. First rule that we have to place the object always left hand side to the mirror. So suppose here, if you consider this one, first look here, we have to place object always. We can place the object right hand side also. If suppose this is concave mirror, so reflecting surface is this side. So that's why we have to place object left hand side to the mirror. If reflecting surface is right hand side, then we can place the object right hand side also. But for our convenience, to simplify the situation, we can take first convention like this. We have to place object always left hand side to the mirror. Means the orientation of mirror will be like this. Reflecting surface will be this side. So this is your reflecting surface. So first rule is that we have to place the object always left hand side to the mirror. Second, all distances are measured from pole. Suppose this is your pole. It's not like to measure the distance, first we have to fix one point. That fixed point is pole. So all distances are measured from the pole itself. So suppose this is your object. So you have to measure from this point. So you are going left hand side to measure the distance of this object. So this object distance will be negative whenever you go left hand side. So okay, so first rule is that we have to place the object left hand side to the mirror. Second rule is that we have to measure the all distances from pole itself. And when you are going left hand side to measure it, then it will be negative. When you are going right hand side to measure something, like sometime image will form like in case sixth situation of concave mirror, when you place the object between pole and focus. In that case, image will form somewhere behind the mirror. In that case, this is your image distance, and image distance, to measure the image distance, we have to go right hand side. So whenever you measure something right hand side, then it will be positive. When you measure something left hand side, then it will be negative. So here in this condition, object distance is negative. Image distance is formed somewhere here. So image distance is also negative. So V is also negative. And focal length is also left hand side, because concave mirror, focal length will be somewhere here. Parallel rays will meet at this point. So this is your principal focus at which parallel rays will meet. So focal length is also negative. So all three are negative in this situation. Positive only in sixth situation, when you place the object between pole and focus. In that case, image will form behind the mirror. In that case, this length which we are measuring will be positive. So like this, we have to decide which measurement we have to take as positive and which we have to take as negative. And without this sign convention, this is given in your NCERT book, and they have defined all distances are measured from pole and distances measured in the same direction. Okay, this is not in 10th. This is the sign convention which will you get in 12th. In 12th also we have the same chapter, light. In there also we have to study about the sign convention, because we have to apply the mirror formula. 1 by V plus 1 by U equal to 1 by F, and magnification minus V by U. This will not change. But sign convention they have defined little differently, because little more sophisticated students are there. So that's why they can understand. So we can place object right hand side also. So that's why they have changed the sign convention, rule of the sign convention. First, now we don't have to place object always left hand side. We can place object right hand side also. So that rule we have removed. But for simplicity, for making the things easy, that we have the sign convention in 10th grade, which is very simple. to follow. Here for in 12th grade we have that all distances are measured from pole. This is there in 10th also, but distances measured in the direction of incident ray is considered as positive. And if you measure something opposite to the incident ray, if you measure something, you are going left hand side, suppose here, this is the direction of incident ray, and suppose this is the object image distance. So, you are going left hand side, means opposite to the direction of incident ray. That in that case, this will be negative. If you are going in the direction, suppose image is from here. So, you are going in the direction of incident ray, in that case, it will be positive. So, in terms of direction of incident ray, we can define positive and negative. If you are measuring something in the direction of incident ray, then it is positive. If you are going against the direction of incident ray, then it will be negative. So, that was the last important topic. Now, some uses of the spherical mirror. These are some uses. First, torch. In torch, this part is as a concave mirror. So, that is why here torch will focus the light. It will not be scattered. So, it will focus. So, that is why it will go very far. Same here also. So, here concave mirror, these are the searchlight. So, first we have torch where we are using concave mirror, second searchlight, third headlight of the vehicles. Here also we are using concave mirror. Here also we are using concave mirror. This is solar heater, you can consider. Light will come and it will after reflection all the light will merge at this point. So, that is why we can convert this light energy into heat energy. So, thermal like solar heater. Then we have shaving glasses are also made up of concave. Here also we are using concave mirrors. So, in case of concave mirror, the bigger image will get virtual and bigger image. Whenever you place, like if you see your face, if you bring your face closer to the mirror, then you will get virtual image and that will be erect also. That is very convenient and we will get the larger image. So, that is one advantage. Same thing with dentist also use the concave mirror to see the because it is very difficult to see this part of the so they use concave. So, magnified image they will get. And then these three are the application of convex mirror. So, in case of concave mirror, first it is converging nature we are using, converging nature in all these three situations, converging nature, and fourth situation also it will merge at the center point. And here also these are the condition where we are getting bigger image, that is helpful, and erect also. Now, in case of convex mirror, we use side mirror of the vehicles are convex mirror. Why convex? Because it will cover the larger area behind the car, like suppose it will cover larger area. So, that will be convenient for the driver. So, that's why we use convex mirror in side mirror. Same thing, and in the junction, like suppose that there is junction of 2 or 3 roads are there. So, at the junction also they place some mirror so that it can cover larger area, and for safety purpose also inside the shop also they can make so that they can this mirror will cover the whole shop. So, convex mirror, what is the advantage? It will cover the larger area and it is always erect. So, that is these 2 points we have to consider. That is why we use in this situation convex mirror. So, these are some uses of a spherical mirror. So, this is the end of this this topic, not chapter. This is the end of this topic. Thank you. Thank you for watching, and see you in the next video where we'll explain about refraction of light.